Hi everyone. So we will solve this same problem in the preemptive mode. Okay. So I will take this example in the earlier video in non-preemptive priority scheduling mode. Now in this video we will solve this same problem in preemptive priority scheduling mode. Okay. So preemptive priority scheduling means we will run each process for a single unit of time, okay, and check whether the newly available process is having highest priority or not. If this newly available process is having highest priority, then we will consider this newly available process and schedule it to the CPU, just like what we are doing in shortest remaining time first and longest remaining time first. But in shortest remaining time first and longest remaining time first, the criteria is different, and here in preemptive priority scheduling the criteria is different. Okay, so based on the criteria given, we need to run the process for a single unit of time. So at time 0, which process is available? Process P1 is available. So we will run this process for a single unit of time, let's say 0 to 1. Now at time 1, how many processes are available? Two processes, process P1 and process P2. And before pick the next process, just see how much time left for a process which is scheduled before the CPU or which is run by the CPU just earlier. So it is 4 minus 1, so 3. Now process, and also in this example 12 represent the highest priority and lowest number represent the lowest priority. Okay, so now we have two processes, process P1 and process P2. Process P2 is having highest priority 4, so process P2 will be the next chosen process. So process P2 will be the next, and again we will run this process by single unit of time. So 1 plus 1 is 2, and now the time left is here 1. Now at time 2, process P1, P2 and P3, all these three processes are available and their burst time are 3, 1 and 3. Out of these three processes, process P3 is having highest priority, which is 6. So process P3 will be the next chosen process, and again we will run it for single unit of time. 2 plus 1 is 3. Now it requires 2 unit of time. Now at time 3, process P1, P2, P3, P4, all the 4 processes are available, and out of this 4 process P4 is having highest priority. Now again it will run by single unit of time, so 3 plus 1 is 4, and the time remaining for process P4 is 4. Now at time 4, 5 processes are available, P1 to P5, and out of these 5 processes, process P4 is having highest priority. So again process P4 is scheduled to the CPU and it will run single unit of time, 4 plus 1 is 5, and now the time remaining for process P4 is 3. Now at time 5, there are 6 processes available. Out of the 6 processes, process P6 is having highest priority. In fact, process P6 is among all the processes, process P6 is having highest priority. It is 12. So definitely process P6 will be scheduled to the CPU, okay, and it will run by, let's say, single unit of time. So 5 plus 1 is 6. Okay, 5 plus 1 is 6. Now the time remaining for process P6 is 3. Okay. Now at time 6, all the processes are available in the ready state. Now whenever all the processes are available in the ready state, or at the time means all the processes you have got in the ready state, then at that time this particular algorithm, this preemptive priority scheduling algorithm, will convert itself to non-preemptive version. So at the time where all the processes are available in the ready state, then you will run this algorithm just like you are running the non-preemptive version of this algorithm. So at time 6, out of this 7 processes, process P6 is having highest priority. So again process P6 scheduled to the CPU and it will run till completion. It requires 3 unit of time. 6 plus 3 is 9. So P6 is completed. Now 6 processes are remaining. Out of these 6 processes, process P4 is having highest priority. So process P4 will be the next process to schedule to the CPU, and it requires 3 units of time. 9 plus 3 is 12. P4 is also completed. After that P4, process P7 is chosen because it is having the highest priority. So P7, and P7 requires 6 units of time. So 12 plus 6 is 18. After that process P7 completion, the next process chosen will be, it is 2486. So definitely P5 is having highest priority. So P5 will be selected next, and it requires a single unit of time. So 18 plus 1 is 19. P5 is also completed. Now the next process will be process P3. P3 requires 2 units of time. 19 plus 2 is 21. P3 is also completed. Then after, the next process will be process P2. P2 requires 1 unit of time. So it is 21 plus 1 is 22. And then finally the last process is P1, and P1 requires 3 units of time. So 22 plus 3 is 25. Okay, so at time 25 all the processes are completed by the CPU. So the next thing to find out is completion time. So before computing the completion time, I have to erase this remaining burst time. Now completion time will be, just see the right number of a particular process, right hand side of a number of a particular process. So process P1 is completed at 25. So completion time will be 25. Completion time of process P2 will be 22. Completion time of process P3 will be 21. Completion time of process P4 will be 12. Completion time of process P5 will be 19. Completion time of process P6 will be 9. And finally completion time of process P7 will be 18. Okay. Now the next thing is turnaround time. Turnaround time will be completion time minus arrival time. It is 25 minus 0 is 25, 21, 19, it is 9, 19 minus 4 is 15, 9 minus 5 is 4, 18 minus 6 is 12, waiting time is turnaround time minus burst time. 25 minus 4 is 21, 21 minus 2 is 19, 19 minus 3 is 16, 9 minus 5 is 4, 15 minus 1 is 14, 4 minus 4 is 0, 12 minus 6 is 6. Now in preemptive priority scheduling, the response time is different from the waiting time. So let's compute the response time also. The process P0 is scheduled to the CPU at time 0 and it is available at time 0. So 0 minus 0 will be 0. So response time of process P1 is 0. Similarly, process P2 is scheduled to the CPU at time 1 and it is arrived at time 1. So definitely here response time is 0. Process P3, 2 minus 2, it is also 0. Process P4, 3 minus 3, it is also 0. Process P4, after process P4, let's go back to the process P5. So process P5 is scheduled at the time 18 and it is arrived at the time 4. So 18 minus 4 is 14. Process P6 is scheduled to the CPU at time 5 and it is arrived at time 5. So definitely here also 0 response time. Similarly, after process P6, process P7, it is scheduled to the CPU at time 12 and arrived at time 6. So 12 minus 6 is 6. So only process P5 and process P6 have their response time as 14 and 6, and the remaining processes have 0 response time. Okay. So that's all about preemptive priority scheduling. In the next video, we will see the next concept in CPU scheduling algorithm.